Ignition sequence starts.
Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Room, where there's a team on duty 24/7, keeping an eye on station operations and assisting the crew members with their work of science research and station maintenance. Expedition 62 Commander Oleg Skripochka and flight engineers Drew Morgan and Jessica Meir have spent most of their time this week working on a variety of science experiments, while also getting ready to greet the arrival of a new cargo ship that's due to launch later today.
Welcome to Space to Ground. I'm Catherine Clayton. This week, the International Space Station crew prepares for a big delivery. NASA astronauts Jessica Meir and Andrew Morgan work to prepare for the SpaceX Dragon cargo resupply, launching on Friday evening, March 6th. The team spent time practicing the robotics procedures necessary to capture the vehicle and dock it to the station. When the SpaceX vehicle arrives, Andrew Morgan will command the Canadarm2 to reach and grapple Dragon, while Jessica Meir monitors the Dragon's approach and rendezvous. The team also spent time spring cleaning around the station to prepare for more than 2 tons of cargo arriving in the Dragon. Thanks to cutting-edge research on Space Station, we are one step closer to manufacturing 3D printed human organs. This week, the crew ran a test print without cells on the TechShot biofabrication facility. The facility is a 3D printer that could produce usable human organs. These organs may one day be used to save lives around the globe. One challenge with 3D printing organs has been the tiny, complex structures found inside the organs. This facility takes advantage of the microgravity environment on the space station to maintain the shape of the structures. This is a small step in the long-term plan to manufacture human organs with a 3D printer in space. March marks the celebration of Women's History Month, and the International Space Station and NASA are celebrating women's contributions to the space station program. As of today, 65 women have flown in space. This includes cosmonauts, astronauts, payload specialists, and space station participants. The first woman in space was Russian cosmonaut Valentina Tereshkova in 1963, and the first American woman in space was Sally Ride, who flew aboard the space shuttle STS-7 in 1983. NASA astronaut Susan Helms was the first female crew member aboard the ISS in 2001, and Peggy Whitson was the first female ISS commander in 2008. In 2010, we have 4 women in space, the most at one time, and just this year we accomplished the first all-female EVA. The contributions of women to the space program are immeasurable. More information about women in space can be found at nasa.gov. Keep sending in your questions using the hashtag AskNASA, and we'll see you next week.
NASA TV and NASA.gov start live coverage of the launch of the new Dragon cargo ship at 10:30 Central Time this evening. Launch is at 10:50, and that'll mean arrival at the station early Monday morning, March 9th, with coverage starting at 3:30 a.m. Houston time. The Dragon cargo ship launching tonight is loaded with supplies for the crew members, plus the materials to support dozens of experiments that'll be done during Expeditions 62 and 63. Now, can you imagine what it must be like for the scientists who spent years of their lives designing and developing an experiment and then having to stand by and watch it blasted off of the planet? Well, in this episode of the new NASA Explorers series, you can watch as a pair of researchers experience the countdown and the launch of their first experiment into space.
It's the launch day. It's a little windy out here today. It's a beautiful day. It's a little windy. It's got me concerned. My launch intuition is tingling a bit. I grew up here in Florida. I came to this very spot out here in the Causeway as a kid. My dad would take us to launches all the time. So personally, it's like the kid in me comes out when I come here. It's really cool. I've been on both sides of it. I've been a researcher, and then I've been now helping researchers. And I got to say, it's nervous on both sides. You have a lot of worry, I guess, as a scientist. You have a lot of work involved. As a payload provider, you hope you've checked all the boxes and you've done all that you can do to make everything work for the researchers so that they get good data. It's not easy to put even the most simplest payloads on the space station. but it's worth it. It's worth all the work. I think some of the biggest discoveries we've made and are going to find are up on the space station. It's incredibly important.
Well, we've been really nervous all the way up until right this moment. Nervous that our dreams aren't actually going to happen. But now that the larger countdown is happening and the rocket's all fueled up and everything looks like it's going to happen on time, it's getting really exciting. The last 15-minute window before it takes off. Thanks to Cases for funding this, thanks to NanoRacks for helping us coordinate and making the hardware and coordinating all the data collection too. And thank you for the astronauts who are going to be working on this project on station. So a lot of people worked on this. It's not just the two of us. It's been a lot of people. So we really appreciate all their support.
7, 6, 5, 4, 3, 2, 1, 0. And liftoff.
As Falcon 9 and Cargo Dragon take flight, bound for the International Space Station with fresh supplies and research, helping to maintain our human presence in space as the station celebrates its 20th anniversary.
It'd be incredible just to watch it no matter what, but knowing that we have a personal investment in it, it makes a big difference.
Yeah, so it's just knowing that something that we've been working on is on it, and then watching the whole experience makes it just different. It really, I can't find the right words to explain it. Really,
Definitely feel like the work leading up to it was worthwhile.
yeah, absolutely. And watching it with your best friend,
Yeah.
and like someone that you've been working with for such a long time, and it's just I think it couldn't get better. That's what I can say.
Yeah.
Yeah, I didn't want to do it with anyone else.
Yeah. That is the exact same sentiment that I have too. So it was really special that we could both be here.
Yeah.
And watch it together.
Our scientist experiment is officially on its way to the International Space Station. The SpaceX Dragon capsule that gives the research its ride to low Earth orbit now must make the last leg of its journey to the hands of the astronauts in microgravity.
What's neat for us is we've got cargo vehicles coming and going to the ISS all the time. It is really like a busy parking lot. Vehicles come in, they stay for a few months, we do a whole bunch of science, and then they leave again. And before you know it, the next one's coming up. Now, what's important to remember is that these vehicles cannot dock themselves to the space station. We have to bring them into the space station utilizing robotics. And what I like to tell people is performing robotics, going out and capturing that vehicle is like a really difficult video game. And so we practice over and over and over again using computer simulations on how to actually capture that cargo vehicle to bring it into station. Once that cargo vehicle docks to station, we do a series of pressure checks and equalize that pressure with the International Space Station, and finally we get to open the hatch. Very quickly the crew starts to move because we've got some experiments that are actually kept at certain temperatures, and we have to transfer them quickly out and keep them at the same temperature there on board the space station.
Elaine and Peristu's research is one of the experiments that requires quick unloading. Stored at a constant temperature to ensure the hydrogels stay intact, it's one of the first items that astronauts must remove from Dragon. Then, with the experiment finally aboard the space station, it's time to conduct science in microgravity.
This was fantastic for me. This is what I do. This means a lot to me as a clinician. And so it was really neat to be able to perform that sort of science on station.
Space Station 1002 is loaded.
At any given time, there are about 300 experiments like the one from Tim Panagen that are being conducted aboard the International Space Station. Just before she left the station and returned to Earth last June, astronaut Anne McClain shared her perspective on the research she helped conduct during more than 6 months in space.
The International Space Station is a national orbiting laboratory. Every single day we are answering big questions about Earth and about space, about where we came from and about where we're going. But the other thing that we're doing is we're learning more questions to ask. And so the question really, I think that's important to say is, who are we if we stop exploring? Every day is the intersection of the magical and the technical. Our jobs require a lot of focus, a lot of heads down, detailed work, but there's always moments throughout every day that you step back and you realize, you know, we're working off the planet in microgravity in one of the most unforgiving environments known to mankind. It's really incredible.
The range of science research being conducted on the International Space Station today is remarkable, and the station program's science office would like to see if you can help expand that range. Got a hypothesis to test that requires eliminating gravity as a variable? Have we got a research platform for you?
Hi, I'm NASA astronaut Megan MacArthur. Did you know there's a research laboratory in space? It's the International Space Station, and it's a scientific stepping stone that's enabling us to explore farther into space while improving life on Earth. The space station provides a unique environment of microgravity, extreme conditions, and an observation platform that enables researchers from all over the world to test theories and technologies off the Earth in an extreme environment unlike any other. We welcome you to join us on station. You don't have to be a rocket scientist or part of NASA to gain access to this unique laboratory. Don't know much about spaceflight? That's okay. We're here to help people just like you every day. You might be curious about funding, capabilities, access, or maybe you just don't know where to start. Give us a call or email. We'll ask you some basic questions about your objectives, which will help us point you to the right people who could make your experiment or testing your technology possible in space. Visit nasa.gov/station opportunities for more detailed ideas, answers, and contact information, or find us at the Station Research Client Helpline. So welcome to the International Space Station. You'll soon be part of a worldwide group of researchers making discoveries on this amazing orbiting vehicle, all for the benefit of our planet and future exploration beyond.
There are several studies underway on the International Space Station designed to help get human beings ready for future missions, like Artemis program missions back to the moon, and after that, missions out into the solar system. Scientists are busy exploring ways to provide those astronauts with the nutrition they'll need to stay healthy when the time comes for them to leave the home planet on journeys that will last for years.
A successful mission starts with nutrition. Presented by Science at NASA. Centuries ago, large wooden ships explored the seven seas. But often a ship that began its voyage with a crew of hundreds could return with tens. The silent killer? Scurvy, a disease that occurs when there's a lack of vitamin C in the diet. On the other extreme, explorers of the North and South Poles could fall ill by eating the liver of polar bears and seals, exposing them to toxic levels of vitamin A. Centuries of exploration have taught us there is a vital relationship between a successful exploration mission and balanced nutrition. And nowhere is that lesson more vital than in the extreme vastness of outer space. NASA nutritionist and manager for nutritional biochemistry Scott M. Smith, Ph.D. notes, "We're studying nutrition aboard the International Space Station, or ISS, by tracking what astronauts eat and how their body mass and health change over time in microgravity. Menus that lack variety and busy schedules can impact the astronaut's dietary intake, and insufficient intake leads to weight or mass loss, bone and muscle loss, cardiovascular effects, and more. The foods on ISS are all shelf-stable. there is no refrigerator or freezer for food. Right now, we're lucky because we're able to deliver fresh fruits and vegetables to the station. But think about the first human trip to Mars and back, which may take 30 months or more. How do we maintain optimal nutrition for our astronauts over that much time? The challenge is clear. In space, the astronauts' environment impacts their nutritional needs. Astronauts have higher radiation exposure, higher atmospheric levels of carbon dioxide, low humidity, and microgravity, which can all have effects on their health. Having a balanced, nutritious diet is important to help counteract spaceflight effects on the body. These can have short-term consequences, like on mood and performance and kidney stone risk, and raises long-term concerns such as bone and muscle loss, cardiovascular degradation, impairment of the immune function, and vision changes. Smith says the foods we give them will be of utmost importance for counteracting these effects, which is why we need to find ways to keep the food palatable, nutritious, and safe, even after it's stored for months or years. Keeping an eye on intake will be important too. Currently on ISS, astronauts use an iPad app to track intake, and this gives them real-time information on their diet. The nutrition team and flight surgeons also watch this information to help provide feedback to astronauts. This attention to astronaut nutrition is also paying dividends for those on Earth. Smith notes that astronauts on board the space station have already delivered a plethora of nutritional data that can be applied to all people. He says we've gained new insights into how nutrition can have effects on all human systems, including dietary effects on bone loss, which affects the elderly in particular, and how to better treat that condition and others. Of course, says Smith, a simple start for people on Earth to maintain optimal health is the same as it's been for centuries. Keep eating your fruits and veggies. For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more appetizing information about space exploration, visit science.nasa.gov.
The job of an astronaut on the International Space Station includes working as a laboratory assistant for scientists doing research in space and doing needed maintenance to keep their home on orbit operating safely and efficiently. They also have to keep themselves in good shape so they can do all that other work. In this demonstration video, astronaut Joe Acaba talks about exercise in orbit.
Hey there, my name is Joe Acaba, and I'm living and working on the International Space Station as part of Expedition 53. One of the best parts about living on the space station is being able to float. Just like you walk from place to place throughout your day, we float from place to place throughout our day. However, we have learned that the same thing that allows us to float, microgravity, is hard on our bodies over time. Our muscles and bones are made of millions of tiny units called cells, and these cells can have problems in microgravity. Up here on the station, bones and muscles no longer have to support the weight of our bodies, so they get weaker. Astronauts could develop something called muscle atrophy, where our muscles become weak from lack of use. Each bone in your body is made of cells too. A healthy bone has more density than an unhealthy bone. Weakened bones can lead to a disease called osteoporosis. Fortunately, our scientists at NASA have figured out one way to keep astronauts healthy and strong. It's called exercise. Let's take a look at how astronauts exercise in space. This machine here is the Advanced Resistive Exercise Device, or we call it ARED. It simulates free weight exercises in normal gravity to work all of the major muscle groups. ARED's primary goal is to maintain our muscle strength and mass so that we have less of a recovery period when we land back on Earth. All right, so there's looking at lifting. But what about a little cardio? We have a treadmill for that. Let's check it out. Staying physically active helps both astronauts in space and humans on the ground to stay healthy. And it prevents muscle atrophy and osteoporosis. Now you can try the activity connected to this video to learn more about muscle and bone cells. I'm Joe Acaba, and I hope you enjoyed learning about exercise on the International Space Station. We'll see you next time.
NASA astronaut Drew Morgan is now about 6 weeks away from finishing his first spaceflight. He'll end up with more than 270 days on orbit. He's made 7 spacewalks of more than 45 hours, and that has him at number 17 all time in spacewalking time. Quite an achievement, to be sure. But for Morgan, he was no stranger to making giant leaps, even the first time he floated out of the station's airlock.
I think I often describe myself as a soldier, a physician, and an astronaut. The pursuit of those happened in that order. One of the earliest memories I have is of always wanting to be in the military, of wanting to be a soldier. Quite a history of military service in our family. Both of my grandparents, my father was an Air Force officer, and I also remember my parents telling me a story about my great-uncle Clink, Harry McClintock, who was a paratrooper in World War II. He was in the 101st Airborne Division and jumped at Normandy on D-Day, and then jumped in Operation Market Garden in Holland. And that was the first time I had ever heard of the concept of a paratrooper or what it meant to be an airborne soldier. So when I later decided, I graduated from high school and I went to West Point, I knew that I was very interested in this concept of being an airborne soldier. At West Point, they had a parachute team called the Black Knights. Yeah, so I made the parachute team, and that became one of the central activities of my remaining 3.5 years at West Point. In addition to academics, after class, we jumped most days of the week, but then we were also a demonstration team, so we jumped in football games. Also, while I was a cadet, I went through military basic airborne course, which taught military static line parachuting. Specifically the parachute aspect of it, if I go back to the time when I was a cadet, my teammates that I was selected with became my best friends in the world and continue to be to this day. And that camaraderie that we had and that dependency we had on each other, making sure that we were skilled in the aircraft, skilled in the air, our lives depended on each other to do safety checks of each other, that type of camaraderie is something that I feel now in the astronaut corps with my astronaut colleagues as well. I think about how 20 years ago I was developing those skills at an early age and didn't even know it. I'm Andrew Morgan, and I'm a soldier, a physician, and an astronaut.
Now, most of the astronauts who've spent time on the International Space Station, or those who've seen Earth from hundreds of miles up, even for only a short time, say that the experience of looking down on their home planet has changed their perspective on a lot of things. For former astronaut Nicole Stott, art is the medium she's using to try to share the experience with the rest of us Earthlings.
The first time I saw Earth from space was on the space shuttle. My first flight, I flew to the station on the Space Shuttle Discovery, and I do not remember if we were over land or water or night or day. I just remember being impacted by the view, like not believing, first of all, not believing that I'm floating in this place that I was in. You know, that was kind of amazing enough on its own. And then to be able to put my face in that window and see home below was awesome. It's like a work of art out the window there, and it surprises you every time you look at it. You get these beautiful twinkly city lights, you know, seeing where all the people are and where they aren't.
And one of the most impressive things was watching thunderstorms, storm activity moving around the planet. It's like watching neurons firing in a brain. These tentacles of light that are just connecting and traveling. Yeah, it might be starting over Florida, but it's moving across the ocean to Africa as far as you can see. And I remember floating there just thinking about, oh my gosh, everything is connected. And if you get it dark in the station, all the colors and the light come out in that depth of space as well. And it's kind of that, I don't really know what infinity is, but maybe that's what infinity is. And just like the clarity of looking at the Earth and the colors glowing there, you get that same clarity in this blackest black I've ever seen. And it feels like you could reach in and like the stars have distance between them. When you're in that place, 250 miles is really not that far in the grand scheme of things, but it seems far when you're in space on the space station or on the space shuttle. I think the perspective is one of like a reality check, of seeing this thing you thought you knew from being right down in it, on it, in a whole new way, and realizing that, oh my gosh, that is a planet, and I am farther away from it than I ever likely will be, and I feel like more a part of everyone, everything that's down there than I had when I was right in the middle of it. We all feel, I think, an obligation to share the experience in one way or another. For me, that's been art. I've tried to use the paintings that I create on my own, the work that I'm doing with other people artistically to share that message. And if I think about my own artwork, whether people like my art or not, really is not all that important to me, but I want to reach audiences that might not even know we have a space station, might not know that for almost 20 years, we have been living peacefully, successfully in space on this mechanically created life support system with people from 15 different countries doing work that is all about improving life on Earth.
If you'd like to get another look at any of these stories that we've showed you today, check us out on YouTube and Facebook. There are the addresses in the corner of the screen. Be sure to look around, too, because there's lots of cool stuff to find about NASA and America's human spaceflight program. And if you're out on the internet anyway, check out Houston We Have a Podcast, where we talk to folks about their work in all aspects of space exploration. The new episodes post on Fridays, and today we talk with International Space Station Chief Scientist Kurt Costello with a fun update on some of the cool new experiments underway on orbit. Go to nasa.gov/podcasts for today's episode and all the previous episodes, and the full library of all the NASA podcasts, which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. And special for today, 12:30 Central Time, a live podcast episode on NASA television with video. We'll be answering questions about astronaut applications. The window for that is open right now at usajobs.gov. This is Mission Control, Houston.